Good morning, my dear students. In our today's session, we are going to have again one of the special practical sessions. So, this is based on what, first of all? This practical session is based on chemistry. The particular topic that we are going to do is not only going to come in class 8 or class 10 or over there, it is also going to come further in the chemistry of your further studies, that is of 11th and 12th. We are going to observe some of the very important thing that you have already studied in your class 8 chemistry. What have you studied now in class 8 chemistry? You have studied about the displacement reaction, right? We are going to practically see the displacement reaction. Let's observe it. What is the displacement reaction now? Displacement reaction means more reactive metal displaces less reactive metal from its solution. The more reactive metal will be displaced by the less reactive metal from its solution. Now, how can that be possible? Yes, try to recall that is the Hera-Feri reaction. Where are we doing it in practicals? Because it is one of the very important part of chemistry, and you should know the reactivity series at the tip of your tongue. I hope you remember in class 8 you have done this. Hardly could make solid gold perfectly. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. PSC, Marcel, hardly could make solid gold perfectly. On the basis of this, we can say potassium is the most reactive element. After that comes sodium. So only these are preserved in kerosene, as they will start vigorously the reaction with the air as well as water. Calcium, again one of the metal which is very reactive. Magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. These are all the parameters, that is the elements that you have already studied about. So I hope you remember this particular mnemonics also to learn it. It was this way. PSC, Marcel hardly could make solid coal perfectly. Now, the very first reaction that we are going to observe is this. To the zinc plus CuSO4, what will happen if we mix these two? If you observe it, zinc, it is coming before copper. So zinc is more reactive than copper, yes or no? Yes. Because zinc is more reactive than copper, then what will happen? Zinc will displace more reactive copper from its solution. Now what is the color of copper sulfate? Copper sulfate is blue in color. What is the color of copper sulfate? It's blue in color. So you will remember also, zinc is not yellow in color, the zinc dust is black in color. So this black and blue colored solution, when they will be mixed, you will get a colorless solution. Why a colorless solution? Because more reactive zinc will displace less reactive copper from its solution. So output will be this way, Zn plus CuSO4 gives ZnSO4 plus Cu, that you have already done in chapter number 4, metals and non-metals, class 8 basic chemistry. More reactive metal, that is zinc, will displace the less reactive metal copper from its solution. So Zn plus CuSO4 will give you what? It will give you ZnSO4 plus Cu. Zinc will displace the more reactive element from its solution and you will have a colorless solution. This is how the whole of the reaction is carried out. Now you just wait and observe how is this practically happening.
Now we are going to see how more reactive metal displaces less reactive metal from its solution. Try to recall the whole of the reactivity series. It is this way: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. So from this reactivity series, we can conclude that zinc is more reactive than copper. In order to explain, in order to understand this, with us we are having zinc dust and the copper sulfate solution. We'll first make the copper sulfate solution over here. Little bit of copper sulfate will be added to this beaker. The chunks won't be used. The copper sulfate is blue in color and you can see it. On adding water to it, we'll just whirl it to make the solution concentrated, and to see that the copper sulfate gets dissolved in it. So here it is, almost ready. The blue color of the copper sulfate solution, almost it has dissolved. In this test tube, we have already taken some amount of zinc dust. We'll now add copper sulfate to this particular test tube that is already containing zinc dust. Let us shake it and allow it to stand for just few time. Let's wait till the solution becomes stable. Just observe the color. You can observe it that it is becoming almost colorless, from blue to blackish to a colorless solution. Let us wait for a few seconds to see it. I hope you are seeing it as colorless solution. So let's wait. So this is how the metal displacement reaction occurs. That is, more reactive metal, which is zinc, will displace less reactive metal, which is copper, from its solution. Finish it.
So I hope you have understood this content properly. Now let's move further. First I am going to explain you one new type of reaction, that is precipitation reaction. In class 8, 9, both the standards, this word precipitation has come somewhere or the other. What is precipitation reaction and what is a precipitate? When two soluble salts are combined and something insoluble is produced, then it is called as precipitation reaction. When two soluble salts are combined and something insoluble is formed, the insoluble thing that is formed is called as precipitate. What is it called as? Precipitate. Precipitate can be of any color and it will never ever depend on the color of the solution. Once again, it will never ever depend on the color of the solution. So, what is precipitation reaction? You can get the precipitates on your own, at your home, by mixing any of the two things. How? That you have to find out. But in chemistry, how we will be doing that, I am going to teach you right now. First, note down this, then I'll explain you the very first precipitation reaction. Quick. Be quick. I am taking 5 solutions. HNO3, that is silver nitrate. FeSO4, or first let us take CuSO4. What is that? Copper sulfate. NaCl, that is common salt. It will be added to the water. Water will be added to all except HNO3. Then FeSO4, that is ferrous sulfate. Then potassium ferrocyanide. We are going to mix this particular any of the solutions and we are going to make the precipitates. HNO3, CuSO4, NaCl, FeSO4, K4FeCN6, all these are what? These are the solutions of various particular things. You don't have to learn anything, but just one by one we'll start. The very first one which we will do is this. HNO3 plus NaCl. If we mix both this solution, then we get the precipitates of white color. The very first one, HNO3 and NaCl. First, one by one, we'll see it. Just have a look at this particular reaction.
So now we are going to practically observe the precipitation reactions of all the things that we discussed in the lecture theory. As you can see, we are having the solution of sodium chloride NaCl, that is water along with the sodium chloride, and that is called as sodium chloride solution. In short, Pani Mummy 2. The next one is AgNO3, that is silver nitrate solution. The next one you are having is a ferrous based complex salt, that is K4FeCN6, which is potassium ferrocyanide. The next one you are having is this CuSO4. After that you are having FeSO4 solution. I hope the colors of all are visible to you. So now you should never forget in your life that what is the solution of FeSO4, how is it colored? Almost brown like. This is blue colored. So which solution is blue in color? It's copper sulfate. Potassium ferrocyanide, which is K4FeCN6, and its color is yellow. AgNO3, you can see it's almost colorless. I'll just turn the beaker for you so that you can observe its color, which is almost colorless. Sodium chloride NaCl, Pani Mummy 2, that means again it becomes a colorless solution. Now we'll see one by one how the reactions occur. The very first one is this sodium chloride with AgNO3. Little bit of sodium chloride I'll add to this beaker. In the next beaker, this is test tube. From the next beaker, in the test tube I'll add AgNO3. I am adding AgNO3 because I'll be using it twice. Now you can observe both the colors. This is totally transparent and this is bit whitish transparent. Now let me just combine it and see the magic. I hope you are able to see the white colored thing. It looks somewhat something like buttermilk, right? No, it's not buttermilk. It's the precipitation reaction that is occurring between AgNO3 and NaCl, and you're getting the precipitates over here. I'll hold it on so that you can see it properly. So, I hope this is clear.
So that's how you saw that white colored precipitates are formed. Let us move further on the next particular reaction. First we did this AgNO3 with NaCl. Now we'll do this AgNO3 with CuSO4. When AgNO3 is mixed up with CuSO4, at that time you get light bluish colored precipitate. So this same AgNO3 plus CuSO4, it will give light bluish colored precipitate. Okay. First, which one we saw? We saw first one, this AgNO3 and NaCl. Next, now we are going to see HNO3 along with CuSO4. This one, and what will we be observing? We will be observing this, that is light bluish colored precipitate. Note it down quickly.
Now let us see the reaction between CuSO4, which is copper sulfate, and AgNO3, that is silver nitrate solution. The copper sulfate solution that is given over here is very much concentrated, so we need to add water to make it dilute. Water, to it is added copper sulfate solution. Little bit is enough so that it becomes a dilute solution. Shake well before use. To this, the solution of HNO3 is added. And here you can see how the color of precipitates are observed. Just let it remain in the standstill position. Hope you will zoom it and see. Just observe the color of it.
I hope you have noted down this. Now let's move further on the third type of precipitation reaction. The third type of precipitation reaction. First, let us have a look at these names. Let us now take little bit of potassium ferrocyanide and mix it with the copper sulfate solution, that is this K4FeCN6 and CuSO4. When we mix this both, that is K4FeCN6 and CuSO4, at that time you will observe that brown colored precipitates are formed. What color? What is the color of the precipitates? It's brown colored. Okay, so you just wait and observe it.
Now let's move further on the next type of precipitation reaction. This is the complex salt, that is K4FeCN6, about whom you are going to study in your later higher standards. You can see it yellowish in color. I'll a little bit shake it so that we get proper K4FeCN6 solution. You might have heard, no? Shake well before use, somewhat something like that. So, yellow colored K4FeCN6. Next, blue colored CuSO4. To this CuSO4, I am going to add this K4FeCN6. Let's observe what is happening. Slowly. Okay, can you see something that got stuck the brown colored precipitate, which is not at all moving. I'll hold on for you. Okay? So you can see it's not shaking also. The structure of it is somewhat, you can see how it has got settled properly. Just observe it. Just observe it. You can just zoom it and see.
After observing K4 FeCN6 and CuSO4, next we'll see K4 FeCN6, that is potassium ferrocyanide. Plus FeSO4. What can you observe now? You will be observing the precipitates of dark blue color. Just wait and watch.
Moving further, this is K4 FeCN6. Next, FeSO4. Little bit of FeSO4 I'll take in this beaker. From this beaker to this test tube. And to that, I'll add this potassium ferrocyanide and FeSO4. Let's mix both of them slowly, slowly, slowly. And you can see the dark blue colored precipitates of K4 FeCN6. So I hope it's clear.
So I hope you have gone through all the 4 types of the reactions. One by one, one by one, one by one. Now let's have a look at especially the precipitation reaction first. What we did in precipitation reaction and what is precipitation reaction? 2 soluble salts, when they are combining, what it is called as precipitation reaction. And what is that insoluble substance called as? It is called as the precipitate. You have not noted down this, so note it down fast. Next, write down the name of all these compounds. If it's this AgNO3, then it is called as silver nitrate. CuSO4, copper sulfate. Common salt NaCl, Me2, sodium chloride. FeSO4, ferrous sulfate. K4 FeCN6, potassium ferrocyanide. Just for the sake of this practicals, only remember this name. AgNO3. Ag stands for silver. Au for gold. AgNO3, silver nitrate. CuSO4, copper sulfate. NaCl, common salt plus water. FeSO4, ferrous sulfate. K4 FeCN6, potassium ferrocyanide. Once again, AgNO3, silver nitrate. CuSO4, copper sulfate. NaCl, common salt, or you can write it as the sodium chloride solution. Its chemical name is this, sodium chloride. Do not forget. FeSO4 ferrous sulfate. K for FeCN6 potassium ferrocyanide. Once again, HeNO3 silver nitrate. CuSO4 copper sulfate. NaCl common salt sodium chloride. FeSO4 ferrous sulfate. K for FeCN6 potassium ferrocyanide. Next, first note down this quick. I hope you have noted it down. Then the very first one which we noted this HeNO3 plus NaCl white colored precipitate. Write it fast, just now, quick. Silver nitrate, sodium chloride. What is the color of the precipitates? White. Next, silver nitrate, copper sulfate, light bluish, quick. Note it down, quick. Then this one K4FeCN6 plus CuSO4, it will give you brown colored precipitates. Then the next one, dark brown colored precipitate. Displacement reaction. Once again, more reactive metal will displace less reactive metal from its solution. The whole of the reactivity series: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. Here it is. Note it down quick. Quickly note it. Then this is what we saw. Note it. Note the reaction also, because this reaction is coming in class 8 textbook. Quick. Ulta reaction possible nahi hoga. That means if to zinc sulfate solution if you add copper, there will be no color change, nothing will happen. कुछ भी नहीं होगा. So ulta reaction possible hai? Nahi. Less reactive metal cannot displace more reactive metal. Note it down. Here indicate blue color solution becomes colorless. Quick. So that was all about it. Then once again the whole of the practical session we started with the displacement reaction. What is displacement reaction? It's this. More reactive metal will displace less reactive metal from its solution. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, iron, lead, hydrogen, copper, mercury, silver, coal. This on this basis more reactive metal will displace less reactive metal from its solution. Then this is what we saw, the whole of the chemical reaction, that is the blue colored solution becomes colorless. That is when zinc is added to the copper sulfate solution, the color of the copper sulfate will become colorless because zinc will displace the copper. Then next we saw the precipitation reaction. That means insoluble substances when they are mixed, soluble salts when they are mixed, you get insoluble substances, that is called as precipitate. And what is the reaction called as? Precipitation reaction. These are the names of the formula you have to remember: HNO3, CuSO4, NaCl, FeSO4 and K4FeCN6. The name along with the formula you have to memorize. Then this is HNO3 plus NaCl, that is the white color precipitates are obtained. HNO3 plus CuSO4, light bluish colored precipitates are obtained. K4FeCN6 plus CuSO4, brown colored precipitates are obtained. Then next, K4FeCN6 plus FeSO4, dark blue colored precipitates are obtained. Thank you, my dear students, for listening to me, and I hope you enjoyed this practical session too. So with this we end up with the session 2 practicals. In our further session, we'll see the new practicals. I hope you're enjoying these sessions. That's all. Bye bye and have a good day.